Hello my dear students, welcome to my channel. In the previous video I have uploaded the basic proportionality theorem, that is theorem 1, and in this session we are discussing about the theorem 2, that is converse of VPT, the just reverse of that one, VPT. So the statement of this theorem is, if a line divides any two sides of a triangle in the same ratio, then the line is parallel to the third side. So according to this, and by using figure, so we will write the data first, that is in triangle ABC, in triangle ABC, or ABC is a triangle we can take. So according to the statement, if a line divides any two sides of a triangle in the same ratio, this is the first part of statement. I have already told you in the last video, that is, if we divide that statement into two meaningful parts, we can get data as well as what we have to prove. The first part, that is, if a line divides any two sides of a triangle in the same ratio, this we can take it as data. In the same ratio means here in triangle ABC, DE is a line drawn which divides the sides of triangle, that is AB and AC, in the same ratio, which means AD divided by DB, that is D divides AB as AD and DB, and again E divides AC as AE and EC, AE divided by EC. Those are same, or the ratios of those two parts are same. So I have written this thing, that is two sides of a triangle in the same ratio. The two sides of this triangle are divided in the same ratio. This is the data. And then, so the next part of this is, then the line is parallel to the third side. This is what we have to prove, which means this line DE is parallel to BC. This is we have to prove. Now the next step is construction. So that is, we have to consider this line DE is not parallel to BC. We have to prove DE is parallel to BC, but we have to consider the contradictory. So if DE is not parallel to BC, we have to construct another line. We can call this as DE dash, which is parallel to BC. This is our construction, that is, we have to construct DE dash parallel to BC only when DE not parallel to BC. So we will write the same thing here. If we have to use if here, if DE is not parallel to BC, if DE is not parallel to BC, then we have to draw DE dash parallel to BC, DE dash parallel to BC. This is our construction. The next step is proof. The first step in this proof is, we have to consider the data itself, that is from data. So we know that AD divided by DB is equals to AE by EC. We call this as equation number 1. So data I have written same as it is, and I have named that equation as 1. And then, so by applying BPT, sir, here DE dash is parallel to BC. So if DE dash is parallel to BC, we can apply, or we can consider the BPT, basic proportionality theorem, for that, that is in triangle ABC, DE dash is parallel to BC. By this condition, I can use AD divided by DB, that is AD divided by DB is equals to AE dash divided by E dash C. This is by BPT, AE dash divided by E dash C. So this is from BPT, basic proportionality theorem. We call this as equation number 2. Now the next step is, so we will consider or compare equation 1 and equation 2. That is comparing equation 1 and equation 2. So by comparing these two, observe the LHS of equation 1 and equation 2. Both are same. So if the LHS are same, RHS are equal. That is AE divided by EC. This is RHS of equation 1, which is equals to RHS of equation 2. That is AE dash divided by E dash C. So therefore the RHS of equation 1 and 2 are equal. Now, so see here, I have to prove E and E dash as same. So for that, so I have to add 1 on both sides. That is AE divided by EC plus 1 is equals to AE dash divided by E dash C plus 1. So by taking the LCM, so here is nothing but 1, here also nothing but 1. EC and 1, the LCM of those two is EC itself. Now by taking the LCM, I get 1 into AE is AE plus EC into 1 is EC. So we have to do the same thing on the right hand side. That is E dash C is LCM for E dash C as well as 1. So now again by cross multiplication, AE dash plus E dash C. This is by taking the LCM. We already know the method to find the LCM. So now from the figure, we know that now we have to observe the figure here. Observe here AE plus EC, that is AE plus EC gives us AC divided by EC, denominator same. Again AE dash plus E dash C, combining those two we get again AC divided by E dash C. If we cancel AC on both sides, which means we have to consider that AC and cancel each other. So I remain with 1 by EC, which is equals to 1 by E dash C. The next step is just to take the reciprocals of these two. That is 1 by EC, by taking reciprocal it will become EC divided by 1, nothing but EC, which is equals to again 1 by E dash C will become E dash C divided by 1, which is nothing but E dash C. So now I will just consider one rough sketch here. That is EC, I can write it as CE and again E dash C as CE dash. So if we consider CE as just 3 centimeter, so if you take 3 centimeter CE, and CE dash will also become 3 centimeter. So observe the figure here. If you want to mark a point E from C for a distance of 3 centimeter, you have to move like this from C to E, you will get 3 centimeter. Again if you want to mark point E dash from C in the same direction, you will get the same point, which means the 3 centimeter from C for both E as well as E dash is the same point. So this statement gives you that E and E dash are same. E and E dash are same. So by substituting this E and E dash in the construction, so that is from construction we have written that DE dash is parallel to BC. This is our construction. So you can observe the construction there. DE dash is parallel to BC. This is our construction. So as we have proved, E and E dash are same, I can replace E dash by E, that is DE parallel to BC. This is what we have required. So hence proved. So we got what we have required. So thank you. Please like, subscribe my channel for next videos.